Last time, we talked all about linear equations, linear equations. Well, now, we know it so well that we're going to do two at a time. We're going to do systems of linear equations. We're still in the realm of reviewing, I hope, but we're going to move along and we're going to have some applications at the end of this show as well. Now, if we're going to do more than one, we're going to have at least two. If we consider two different lines, what can happen? Well, they're either going to look like this. What do we call that? Parallel means they never meet. Now, how did we know that? Do you remember? They had the same slope. So they're either going to be parallel, or what's going to happen? They're going to touch. We call that they intersect. And these are the ones that are going to be way useful because they're going to have a point in common. And what we're going to be trying to do is solve this system, solve or find that point that they have in common, the point that's both on the purple line and on the red line without drawing a picture. We're going to do it algebraically. Now this is review. There's going to be two ways to do this, and I'm going to need you to know both ways because one's going to be way easier depending on the situation. Okay? The first is the substitution method. To do the substitution method, there's several steps. First thing we're going to do is take one of the two equations and solve it for one of its variables. And which one? Well, whichever you think is easiest, and we'll help you pick that out. Once you've done that, we're going to substitute the expression that's equivalent to the variable that you solved for in step A into the other equation. And you know, that'll leave you with an equation that only has one letter, one x or one y or something. And that's solvable. Okay, we can't solve it when it has two letters. Once you've solved that, you're going to substitute, when I say you solved it, you found a number. You're going to substitute that number, that value you found, into either, whichever is the easiest, either of the original two equations and solve for the other variable. And then,
I can do that, but I don't want to.
yes you are, you're going to check the solution. And the solution is going to be a point. It's going to, remember, a point is two numbers, an x and a y. Okay? Well,
Allow me to demonstrate.
let's try it. This one we'll start off with an easy one. Okay? First step is to solve for one of the two equations for one of its variables. Now, whichever is easiest. Well, one of these is already done. That blue one is already solved for x. So that's, we'll pick that one. Thank you very much. Okay? So we've solved that one for x. Now we're going to take what x is equal to, what is it equal to? It's equal to 3y, and substitute it into the other equation instead of x. The 3y into the other equation instead of x. Let's see. See, I put 3y instead of x. Now I've got an equation with, I say, a single variable. This equation only has y's, and I can solve it. 3y plus 1y is 20, so 4y is 20. Solve it by dividing by 4, and y is 5. I now have a value for y. I don't got to treat it like y. I know y is 5.
Oh, yes.
And that helps a lot. Okay, now every place I see a y, I can put a 5.
Going so soon? I would hear of it.
Well, we're not done yet. We have to find out what x is. And the way we'll do that is, of course, we have more information now. We'll put, instead of y, we'll put a 5. And I'm going to pick whichever the easiest equation is. In this case, it looks like the blue one's easier, but you know, you can't make a wrong guess there. So instead of y, I'll put a 5. And thank you very much. This is going to be easy. X must be 15.
Woohoo! Come to Papa.
Now I know what x is, and I know what y is. So the solution to this system, the point that they have in common, mind you, I haven't even seen it, is x is 15 and y is 5. Or we could call it fancy schmancy, the point 15, 5.
How sweet it is.
You found that point without even looking at a graph. Now wait a minute.
I can do that, but I don't want to.
We've got to check it. We've already kind of put it into the blue equation. Now let's put it into the other equation, x plus y is 20. Does it work? 15 plus 5, son of a gun.
Excellent.
It does work, so I know I'm right. It worked in both equations, and it's the only point that works in both equations. Oh, we better do another one, okay? Remember what to solve this system, to find the one point that they both have in common using substitution. We're going to solve one of these two equations, either the blue one or the green one, for which variable? What do you think is the easiest? Who's the closest to being alone? It's one of these four. What do you think?
Well, duh.
I'm going to pick y because there's no number in front of him. He looks the easiest to solve for. Okay? Shouldn't matter, but I might as well make it easy on myself. Okay? Now who's keeping y from being alone? The 3x, right? So I'll subtract 3x from both sides. And I'll have the blue equation solved for y. Okay? That's step one. Solve one of the equations for one of the variables, whichever is the easiest.
Now what am I going to do?
Well, now we take what that y is equal to. What is it equal to? Minus 7 minus 3x, and substitute it into the other equation instead of y. See what I did? In every place there was a y, I put minus 7 minus 3x. And now I have an equation with only x, and I can solve it. Okay, let's solve that equation. Let's see, minus 5 times minus 7 is positive 35, and minus 5 times minus 3x that's where the 15x came from. Now I'll put these two like terms together, get 17x, and now I'll solve for x. Let's see, subtract 35 from both sides, and I get 17x equals negative 34. Now let's see, I got to divide by 17 both sides, and x is negative 2. And remember, my answer is a point. It's two numbers. Okay, it's an ordered pair, but at least I know the x.
The important thing is it your final answer?
It's not my final answer. I still have to find the y. How am I going to do that? Well, I have new information. I know x is the value negative 2. So I'll look at the other equation, and instead of putting x, I'll put negative 2. Now I have an equation with only y, and I'm a mean, lean equation solving machine. Let's see. 3 times negative 2 is negative 6, and all I got to do is get rid of that negative 6, and I'm there. So I'll do the opposite to both sides, add a 6, and I get y is negative 1. And it looks like I've got myself a pair. The solution to this system, where the two lines meet, is the point negative 2, negative 1. And I've done it. But, oh, you've got to check it, bub. Put it into both equations. I did it in the one. Now let's put it in the other. Make sure it works. Put in the negative 2 for the x and the negative 1 for the y. And let's see. Negative 2 times negative 2 is negative 4. And negative 5 times negative 1 is 5. And son of a gun, they do work. So you know you're right. So always check it in both equations. Okay?
Thank you, sir. May I have another?
Okay, we'll do one more. This one's a little tougher. Let's see. We're gonna remember how we start. Solve one of the two equations. You get to pick which either equation, and you get to pick whatever variable. Who's the easiest here? Who's the closest to being alone? I'm thinking the green x. You with me? Because it doesn't have a number in front of it. That's the closest to being alone. So let's get him by himself by subtracting 3y from both sides. Okay? So x is minus 3y. I've done the first step. Second step is to
What's all this jabberwocky when there's work work to be done.
Okay, let's get going. We got to take what x is equal to, negative 3y, and put it in to the other equation instead of x. There's the minus 3y. And now, you see I have this equation that has only y's, and I can solve it. It may not be easy, but I can. 10 times minus 3y is minus 30y. And put the common terms together, the minus 30y and the minus 5y, and get minus 35y. Now let's see. Got to get y by itself. Minus 35 is multiplying it. So I'll do the exact opposite. I'll divide by minus 35. And I'll get y is negative 21 over negative 35.
Why does this keep happening to
I've got to reduce, remember? I divided top and bottom by a common, let's see, I divided top and bottom by negative 7, and I got 3/5. Now this is the big leagues.
Yoink.
We are going to get fractions. I told you, this is the big leagues, okay? But anyway, we've got our y. It's 3/5.
Not because they are easy, but because they are hard.
We can do this, even though it's hard. I'm going to take 3/5, put it into the other equation instead of y. Just like I did before. Okay, now 3 times 3/5, remember 3 is 3 over 1, is 9/5. Now, I'll subtract 9/5 from both sides. X will be negative 9/5. And I actually have an answer here. I have an x and a y, believe it or not. I know, it looks hard, doesn't it? But it really is an answer. It's a pair. I've got to check it, though. Let's put it in. And when it checks, it'll be crystal clear to you. Let me show you what I mean. For the x, I'm going to put negative 9/5, and for the y, I'm going to put 3/5. Now, let's see what we get. 10 times negative 9/5 is negative 90/5, and negative 5 times 3/5 is negative 15/5. You know that negative 90/5 comes out exact to negative 18. Son of a gun. And negative 15/5 comes out exact to negative 3. How sweet is this? Negative 18 minus 3,
Certainly.
it works, is negative 21. So good thing you checked, but when it checks, it's going to stick out like a sore thumb that it worked, and you'll stick your chest out because you'll feel good.
How do I do it?
It's a tough one, but you did it. Okay, so that's the substitution method.
Pay attention to me, boy. I'm not just talking to hear my head roar.
Let's review. See if this makes sense to you now. We're going to solve one of the two equations for one of its variables. You get to pick which equation and which variable, whichever's the easiest to you. Once you've done that, substitute the expression that that variable is equal to, or equivalent to, into the other equation. And now you'll have a single variable equation that you can solve, and it'll give you a value. Take that value and substitute it into the other equation, and solve that one for the other variable. And then, of course, final step, don't forget to check your solution by putting both the x and the y into both equations. Okay?
And now for something completely different.
Now, there's another method that's going to be of use for us to know, and that's the addition method. I'm hoping you remember that too, but it's worthy of review. Let's take a look.
Oh, no.
What do we do?
Otis.
Sometimes, and when we're going to use this, is it's going to get messy trying to solve for one of those variables. You're going to have a fractional nightmare. Okay? The substitution method will always work, but sometimes it's going to get quite messy.
Otis.
When this occurs, I'm going to give you another method other than the substitution. It's going to be a little easier. And it's going to be called
Oh, will you help me? Can you help me?
the addition method. Absolutely, it can help you when things get messy. And here's the steps. So we may need, we're going to have both equations, we may need to multiply one or both of them by some magic number, which I'll show you how to get, to make one pair of the coefficients, that's the number in front of the letters, become opposites. And once they become opposites, I'm going to add the two equations. And if they're opposites and I add the two equations, one of the variables is going to drop out. And then once again you'll be at the point where you can solve a single variable equation. You'll only have one variable because you made one drop out. And you'll have a value, and the end is the same way you did in substitution. You're going to take the value, plug it back into the other equation, and solve for the other variable. And then the end is the exact same, the last step.
Oh, what a chip.
Yep, you still have to check your solution, which, remember, is a pair of numbers. The first number is the x, the second number is the y.
And now, ladies and gentlemen, let's get ready to rumble!
Okay, now this one's, as our first example, is actually kind of easy because we already have some opposites. It would have been messy. Wouldn't it have been messy to try and solve for one of these letters? I'm going to use the addition method. This reeks of the addition method. Let me show you why. Look at those two babies, positive 2 and negative 2. They're begging to be added because they're opposites. So I'll add them, and look what happens. That's gone, which is what you wanted. You can't solve something with two letters, two different letters. And we got rid of one of them, and we added and got 8x equals 11 plus 20 equals 40. Well, now we have an equation with only one variable. And we'll solve it. Divide by 8. And x is 5. Now I have added information. I know x is 5, and it's going to be very similar to what we did in the substitution method at the end.
Alrighty then.
We're going to take that x, or I should say that 5,
Now what am I gonna do?
and we're going to plug it into either equation. Doesn't matter which one, whichever looks easiest to you. Plug it into either equation. Instead of x, put a 5. Okay? Plug it back in. So I'm going to use the second equation. Instead of x, I'm going to put a 5. And 5 times 5 is 25. Now I have an equation with only y, and I can solve that. Let's see. Who's keeping y from being alone? The 25 and the minus 2. Let me subtract 25 from both sides. And what do I have? I got to get rid of that minus 2. He's multiplying, so I'll divide. And I get y is minus 2.
Cool.
So I have a pair.
The important thing is it your final answer?
Well, my final answer is a pair. It's the point 5, negative 2. It's the pair 5, negative 2. But what do I have to do before I'm positive? I always have to check. And we kind of checked it into the second equation by doing it. Let's check it into the first equation. For the x, we'll put a 5, and for the y, we'll put a negative 2.
Don't make me angry. You wouldn't like me when I'm angry.
Check it every time. Let's see. 3 times 5 is 15. 2 times negative 2, negative 4. And they do add up. We got it. And we didn't use substitution that time. You see, we used addition because we had opposites.
Then you'll come again.
Now, what if we didn't have opposites? This one probably, not a good example really, because I'd probably use substitution for this because the first blue x is by itself almost. But bear with me here. I'm going to lead you into something that's going to be like addition. This one doesn't have opposites. So I'm not ready to add yet.
Oh man.
That's not opposites.
Not.
And that's not opposites either. That's a 1. So I'm going to make opposites.
So why don't you fix it, meathead, huh?
That I will do. Now what am I allowed to do? I'm allowed to multiply both sides of an equation by something, anything, as long as I do it to both sides. Well, consider this. What if I multiply the first equation by minus 3? Now you got to do it to everybody. Watch what happens. Now I get an equation, minus 3x minus 15y equals minus 54. And now I do have opposites. Now where did I get that minus 3? Well, I looked at the positive 3 and I said, I got to make an opposite. Okay? And now I can add them. And look what will happen. I've created opposites. That'll go away, which is what I was hoping. And I can solve for the remaining variable, the y. Let's see, minus 13 is multiplying y. Remember this? We finish it off the same way. Now solve it. Divide by minus 13. And y is 5. I'm on fire now because I'm going to finish it the same way. Now that I know y is 5, I can put 5 in to whichever I think is the easiest equation. I'll use the first one. The original first equation. I'll put a 5. See? And let's see, let's solve for x. I know y, so I got to find x. Subtract 25. And apparently the x will be
Next.
minus 7.
Does this answer your question?
There it is. The pair negative 7, 5 is your answer. What is the last step again? We've got to finish. Come on, always finish. Let's check this, Chumley. We kind of did it with the first equation. Let's use the second one. Put a negative 7 in for x and a 5 for y. What do we get here? 3 times negative 7 and 2 times 5. I get negative 21 plus 10, and it does.
It is a lie.
It does equal negative 11. It works. So there it is. So sometimes you're going to have to multiply through by something, and that's going to be the hard part, figuring out what to multiply through.
Brilliance. That's all I can say. Sheer, unadulterated brilliance.
Well, I'm going to give you one way that'll always work, so it won't be that tricky. Look at this. We're trying to find something to multiply by to get opposites. Remember, that's your goal. Holy cripe. You think of anything? I don't know. Well, here's the deal. Watch this.
Oh, man.
That's not opposites. That's not opposites. What am I going to do?
What you are about to see is bizarre, unsettling, and riveting.
This will work every time. You're going to love this. Watch it. How am I going to cancel these things out? I'm going to take that 3 in front of x and put it there. And then I'm going to take the 2 and put it there. Multiply them. But I'm going to take and then add a negative. Okay? Notice I added the negative of that. That way I'll have opposites. And this will work every time. You take one number and switch it to the top, and one number from the top and switch it to the bottom, and then make it negative. Now that's going to make this one 6x. I don't even care about the y's for right now. And this one minus 6x. And that'll work every time. You'll have an opposite. Okay?
And that's how she wrote.
And I got them.
Let's look at the replay.
Let's do that slowly. I took the 3 and moved it up to the top. Then I took the number in front of the x up top and moved it down to the bottom and made an opposite, negative. Then I multiplied both, and son of a gun, I've got opposites. It'll work every time.
Ay, caramba!
Okay? Now step B is to add them. That'll go away. And let's see. Holy cripe, it's going to be a fraction. I'm going to divide by negative 11. And I always tell people to write the negative in the top. Okay, that'll see you all the way through your math, all the way through advanced calculus. Put negatives in the top. You get to pick top or bottom. Put them in the top. So this really is negative 4/11. This is the big leagues. We can get fractional answers.
I'm simply saying that life finds a way.
And we're going to find a way to plug that in and find out what x is.
Hey, wait just a minute.
We've got to finish. Plug it back into one of the two, either one. Okay, and I'm going to plug, believe it or not, I'm going to plug minus 4/11ths back into this equation. Okay, now how have I told you to solve that? See how I put it in? Negative 5 times negative 4 is 20. Okay, now how do we solve this equation? What was the trick to solving an equation that had fractions in it? Remember your buddy LCD man, and he will get rid of the fractions. If you multiply everybody, you got to be fair. So 11 times 2x is 22x. 11 times 20/11ths gets rid of the 11, so hi mom. And then 11 times 4, don't forget him. Now all I have to do is solve for x. Subtract 20 and divide by 22 and reduce, and I get the answer is 12/11ths.
Excuse me, Professor Brainiac.
What did I forget? That's the point. 12/11ths minus 4/11ths, that's where it intersects. You're going to get caught if you don't check this solution into the other equation, because it may not work. Maybe you screwed up. Let's try it. If it does work, it'll stick out like a sore thumb. Let's plug it in. Instead of x, I put 12/11ths. And instead of y, I put minus 4/11ths. Well, let's see what we get here. I'm going to get 3 times 12, or 36/11ths. And minus 2 times minus 4, 8/11ths. 36 plus 8.
With all due respect, sir, I believe this is going to be our finest hour.
Oh, baby. 44/11ths equals 4. So it works. It's not going to get any harder than that. Okay? So there's your pair. There it works. That's the point. The point of intersection. And we did it blind. We didn't even see the graph of these two lines. We used the addition method.
You've absolutely proved to yourself and to the audience that you deserve to be in this competition at the
Not too shabby. So let's review the addition method. Well, we're going to use it when we can't use the substitution method, when we can't isolate one of the variables easily. So multiply one or both of the equations by some number so that a pair of coefficients become opposites. And once you have the opposites, add the two equations. One of the variables will drop out, so you solve for the other variable. Take what that variable is equal to, the value that it's equal to, and plug it into the other equation and find out what the second variable is equal to, and then check the solution. Okay? Okay, now that's basically the two ways we're going to use. We're going to use all semester to solve systems, to solve more than one line at a time and find that point of intersection. And I'm going to expect you to be able to do that. Okay? Now we have a little time.
How about little fires, Scarecrow?
So I'm going to do a couple word problems somewhat related to this. Okay? Let's see. Acme Calculators is producing a new model of calculator, I guess. They want to kind of start up a new part of the business. They estimate the fixed cost to be $100,000. In other words, they're going to have to create a factory kind of a thing, one-time cost of $100,000. The direct costs, or we call them marginal costs, will be $50 per calculator to make it. Okay, it's going to be a real nice calculator. They're planning to sell the calculators for $75. Now, here's what I would like you to do. We're going to find a cost function, okay, some c of x function to calculate how much, however many calculators we make, is going to cost. Okay? Well, in this case, the cost function is the fixed cost plus the marginal cost. So we say the fixed cost plus the direct cost, same thing. And it's going to be 100,000 plus 50 for every calculator. So 100,000 plus 50x. That's what we'll call the cost function. The revenue function, and the cost means how much it's going to cost us to make it. The revenue function is going to be how much money we're going to make for each calculator that we sell. Well, I already told you we're going to sell them for $75 each. So the revenue, or R of x, is going to be 75x, $75 for each one that we sell. Okay? Now, hopefully we're going to make a profit. So the profit function, it shouldn't surprise you, is going to be the revenue that we make minus what it cost us. So R of x minus C of x, or 75x minus what C of x is, 100,000 plus 50x. And we're going to have to make a whole lot of calculators to make up for that 100,000, aren't we? So typical questions might be, how many calculators are we going to have to make to break even, just to break even, okay, to get that $100,000 back? How are we going to do that? Well, I'm going to set my cost function, C of x, equal to my revenue function. 100,000 plus 50x equals 75x, and find out, basically where the two meet. We're solving a system here. Now, subtract 50x from both sides. What do I got? I have to divide by 25. And x is 4,000, meaning that we're going to have to make and sell 4,000 calculators before we even break even. But if we're a national company, that's not that big of a problem. Okay, 4,000 calculators. Now let's think about this. We're hoping to make way more than 4,000. Somebody might ask you, what is the average cost per calculator to you when you make 25,000 calculators? Now I'm talking about the average cost. That includes the fixed cost. Okay? Well, the total cost, we use the cost function, the total cost of 25,000 calculators is 100,000 plus 50 times 25,000. And if we divide by the number that we make, we'll get our average cost per calculator. So in this case, I'm going to put the cost function in with 25,000 as x, and then divide the answer by 25,000. That'll give me the average cost per calculator.
No problemo.
You can use your calculator for this. Okay, we're more into theory than we are into anything else. And the average price, if you sell a lot of them, remember we learned last class, the more we sell, the more we make, is $54. So son of a gun, if you sell it for $75, we'll make a boatload. We'll make about $21 there. Okay?
Thank you very much for joining us tonight. We'll see you tomorrow. Good night, everybody.